Hello everybody. What I'd like to talk about in this video are histograms and frequency tables. And so what we're continuing to work on the same data set which was shown in the video on pivot tables in Excel. And this time around we're basically going to take some of this data and we're going to probe it further and try and get some extra information out of it. So a histogram is basically a means of counting up of a large set of data, counting up all those data points which satisfy a given condition or which fit within a given range. Basically what we have here are a list of the total volume of stream flow which has come through a particular stream for a given month in given periods of history. And what we're going to do, or what we would like to ask is, okay, how likely is it that a given monthly stream flow total will occur in any particular month? Or will occur, just generally speaking, how likely are monthly stream flows of 148,000 megaliters or 23,000 and so on? And the way we're going to do that is by getting Excel to basically do all the hard counting for us, and we just need to give it a few pieces of information about how it's going to actually group those sorted categories together. Okay, now histograms depend upon these things called bins, which, to give you an example, we might call our bins here, or give the bins categories of 100, 200 and 300, which Excel can then go through this list, and every time it counts something which is between 0 and 100, it puts a 1 in this box, and then it'll go down and count from 100 to 200, puts a 1 there, it finds another one of these, it goes through, it counts another one of these, and so on. It basically just builds up the list incrementally by counting up all of the available data. Now, you can see the data that we have here is significantly larger than 100, 200, 300. So one of the first things we'll address is how you can actually pick bin sizes which are appropriate. One of the ways we might do that is first by asking Excel to give us some data relating to, or give us some summaries of the data which we already have. So I'm going to ask Excel for maximum data. We're going to get some minimums as well, some means. Just go through and work out a few of these things. So I'm going to copy this formula down a few times. And then we'll change these values. So we've got max. Let's ask what the min values are. This gives us an idea of basically how much spacing we need. What's the average? That is the mean average. Oops. Average. And maybe we'll ask for mode as well. That should surely work. No? Alright, well, forget about mode then. Oh, median. Ah, that's right. So we're getting the result NA for mode here because you can see all the data points that we have here are going up to several significant figures. We have 8 significant figures in this case, 8 there, 9 significant figures down there. So the chance of all of those lighting up and providing any two variables which are the same is quite unlikely. Therefore, the mode isn't going to particularly show up to us. We can still ask for the median though, so that's giving us some idea. And maybe one last thing, standard deviation from the mean might also give us some information. Okay, so we can see that our standard deviation is on the order of 100,000. That's showing us the data is pretty widely spaced, and our mean is around the 54,000 mark. Now, I've got some bins in mind because I've been through this video once before and found some which are appropriate, but it did take me a couple of goes to find the right zone. Sometimes you do need to, even after looking at the sort of general range that you're dealing with, you might still need to have a couple of attempts at providing bins until you make the data take the form which is most visually easy to use. So the reason I've adopted these values now, we need something not too small. Our min value is only near onto 1,000. We need to go up to quite large values. So we need to go all the way, well, not all the way up to 1 million, but we need to get pretty close to that area. And we're also, as I said, the standard deviation is quite large, so we're dealing with quite a wide spread. Now you might be tempted to, when spacing out this data, say, okay, well, we can start with a small spacing down here, and then maybe we'll increase the spacing. Maybe we'll go up to spacings where we start to count in increments of 10,000 or increments of 20,000. But you can run into errors where the data starts to become skewed, or will at least look skewed if you do that. Because in the end, we're going to produce a frequency plot which will, if the boundaries between bin values starts to increase, it's going to put more data into those, or count more data that fits in that range, simply because the range spacings are increasing. So to keep things simple and to keep things consistent, we're going to use the same spacing of 5,000 the whole way through, and we're only going to go up to 500,000, even though the max data is about 1 million, because there are very few data points which are actually that large. And we can see from our histogram in the end how many data points will be outside of our bin ranges. Okay, now we want to actually produce our histogram. The way to do that is through the Data tab, and we're going to get Excel to load up all of this data for us. So if you click Data Analysis on the Data tab, there's a number of different kinds of data analysis you can use here. The histogram is one such, and we need to feed in some information. So our input range is that data which we're going to count and sort. So that's all of our monthly data shown here, making sure not to count that grand total cell down the bottom. And our bin range are the bins which we've specified here. We're going to output this to a new blank worksheet, and we're going to make the chart manually. We don't want it cumulative, so we're going to just leave all those settings as they are, and we hit OK. And you see now we've counted for all of these different bins a certain frequency of results which fit within those categories. Okay, so far so good. The raw output from a histogram is this frequency which is in whole units. I'm going to make a percentage frequency plot or column, and basically just find the percentage frequency by looking at the total sum across this range and dividing it by that top cell. As we drag this, so as we take the numerator of the particular frequency immediately to the left of the cell that we're calculating, and we drag it down, we want this sum reference to keep talking about the whole range of those frequency values. So we don't want that to move. Hit F4 to make it an exact reference. B2 will move, and now we should be able to click and drag this down, and like so we have some percentage frequencies, or at the very least at the moment they're decimal frequencies. If we select the same range, we can simply hit the percentage button to change the formatting like so. Okay, great. We've started to populate this list with some data. We've got our bins, we've got our frequencies. To make this data actually visually appealing, at the moment it's just a list of numbers, which is somewhat difficult to understand. We're going to turn this into a graph. Now, there's a number of different choices of graph which we might use here. I might start with column, but then I'll show some of the advantages that we can have with a slightly different kind of graph as well. So, for our column data, our Y values for these columns are going to be all of those percentage frequency values that we just looked at. And our X-axis category labels are going to be all of the bins, including the bin more. Remember I mentioned earlier that the histogram will tell us how many data points are outside our bin, maximum bin of 500,000. Well, it turns out there are 4 data points larger than that, but we can plot them anyway on this bar chart. And we look at that, we have now our data plots which show us a reasonable view of the basic probability of finding any particular flow along this river. Of course, we want this chart, the idea of producing a chart in the first place is to give us a very concise summary of all of the information which a large amount of data contains. And if we want that to be easily visible at a glance, we obviously need to label this. So let's make sure that we put on some chart labels. So this is frequency of flow or stream flow. I should even say it's frequency of monthly streamflow. And along our primary horizontal axis, what do we got here? We just have stream flows, units, megaliters per day. Sorry, just megaliters, that is, because we are dealing with months here. Remember, we've summed over months. And our y-axis, vertical axis, is going to be frequency. Okay, so there's one plot, and that's, again, shows us reasonably quickly at a glance what kind of likelihood there is for a particular kind of monthly stream flow. You can imagine if we were attempting to allocate certain amounts of water to recreation or to natural wetlands or to farmers or anything like that, it would be a good idea to know the frequency of flow coming through that river, so we can then tell stakeholders, okay, how likely is it that you're going to be able to get a 1/4 share in the flow, and what's that going to be. Okay, the bar chart, so far so good, it's looking okay. Let's show another kind of plot though and see if we can get any benefit out of a scatter plot here. So what we're going to do, we basically do the same steps. We're going to still select the same data. Our X values are still going to be the bins. This time we can't select that last cell more. We have to unselect that because it doesn't actually have a value, being a word. And we're also, so we're just going to ignore that last little part of the chart. We can still record all of the other frequency data, and you can add it in like so. Now, so far, it's not looking any better than the bar chart. In fact, it looks pretty much identical to the bar chart, except that we have data points along the top, and things get pretty squishy the further we go along. But there's an advantage that we have in XY scatter plots, which is that we can plot one or both of these axes as logarithmic. Now, we probably want to keep the vertical axis as linear, because it makes most sense to read that frequency as a linear change. But this flow data will cover such a broad range of possible data points that really a logarithmic scale is going to be easier to view. So we can simply right-click, format that axis, and tick this box, logarithmic scale. That will go from, in the base 10 system, we'll go across the range that we've shown here. You'll notice as well we have no data from 1 to 1000, so I'm also, while I'm here, going to specify that minimum point as being 1000, just so that we have basically shown a narrower strip of the graph, and it's again a bit clearer to see. So now we've got the same information as is presented here, but it's viewed in a slightly different way, and we're able to more easily make sense of this broad range where not really much is going on. It fits in a little bit more smoothly on this logarithmic scale. Again, we still want to make sure that we have the appropriate chart titles and chart overlays. So as long as we've done all these things, we've got our chart titles, we've got our axis titles, then we're going to be looking in a pretty good position. Okay, so I hope that has been a helpful video. We've seen that we now have a number of different ways of manipulating data in Excel. If we need to be able to produce these kinds of plots, histogram is a great way to do it. And of course, the combination of a pivot table and a histogram together, you can really sort data and show particular trends, or draw out answers to particularly obscure questions, but questions which have a very important application in some circumstances. So thank you all for watching. I hope you've enjoyed this video, and I'll see you all in the next one. Bye.